Hello. At the end of the previous video, I explained how we choose the confidence level, which is not just choice, it's ad hoc choice, and how to choose a point estimator. And then it remains to calculate the marginal beta. And how we calculate that? The starting point is this. So the only information we can utilize is this, the probability that the confidence interval x bar point estimator minus marginal beta and point estimator plus marginal beta contains the true parameter. This probability is the confidence level, the probability of correct estimation. This probability equals 95% because this is what we choose. And then here, let's think about this. When you have this equation, first, mu is unknown and non-random parameter. It's fixed, right? And m is what we want to solve for. So this, we are going to solve for m. This is unknown. And x bar is random. So random, unknown, non-random, right? These are the basic ideas how we solve out this equation. So that means the only random guy is x bar. So this probability is applied to x bar. mu and m are not random. So this probability distribution is based on the sampling distribution of x bar. And now then you have to think about the sampling distribution theory. We read the results we learned. So x bar is approximately normal with some parameters. And then because x is the only random variable, we are going to rewrite the inequality inside the parenthesis this way. So isolate the random variable in the middle because it's more convenient to solve out. So like it's move around the terms, then you will get this. I believe you can do this. And then remember, we are going to use these results. We have to know the sampling distribution of x bar. And we learned the expected value of the sample average is the true population mean, which is actually the parameter we are estimating. And the standard deviation of the sample average is the sigma, the population standard deviation for a single outcome divided by square root of n, right? So we learned this earlier. And then using these two as the parameters, we can write x bar follows normal distribution mu comma sigma squared over n. By the way, remember here, mu is the population mean of a single outcome. Sigma squared is the variance of a single outcome, population variance of a single outcome, and n is the sample size, and x bar is the sample average. So these are population parameters, but x bar is sample average. So this is non-standard normal distribution, so we use the standardization process. Subtract the mean and divide by the standard deviation. Right? This way, then it will follow standard normal distribution. Right? So remember this form. This standardized form will be used a lot from now on. So maybe it will be, you will get familiar with this form later. So then automatically it is standard normal distribution, approximately. Then okay, now we learned how to standardize x bar. Then apply that. So x bar will be standardized in this way, right? Subtracting mu and dividing by sigma over square root n. then you have to do the same thing for both sides, in this side and this side, subtracting mu, dividing by sigma over square root n, right? And then mu is nicely cancelled out, which is really convenient because we did not know what is mu, but now we don't need to know this. So anyhow, we do not know mu, but we don't need it in the end. This is the standardized probability. In the middle, z is the standard normal distribution, and standard normal distribution between plus minus something. This is something, something. Same thing, but the sign is different. With right, the same thing up to the sign, and its probability should be 95%. How can we find these numbers? Now you have to use the standard normal distribution table or calculator, right? So what we want to find is this structure. Something plus minus something contains 95%, right? So plus minus A contains 95% of the standard normal distribution. Actually, we in a exercise, we considered this value. The answer is to find that value A. To find that value A, you have to think it this way. So 95% is in the middle. That means outside has 5%. 5% is on the outside, but there are two tails, so each tail has 2.5%, respectively. Therefore, smaller than minus A, the cumulative probability up to minus A equals 2.5%, right? And either way, you may use the other way, or you may use this. So A is top 2.5% value. So both are correct statements. You may use cumulative probability or top certain percentage value, whatever you're convenient. Anyhow, you have to get the answer. The another way is to find this. Cumulative probability up to this point is 97.5%, right? You may use cumulative probability up to minus A, but if you don't want to use minus, then you may use A with 97.5%, right? All are equivalent. And we did some exercise to calculate this value in an earlier chapter. So if you are not sure how to find it, I recommend you to go back and review the normal distribution chapter. And if you use a calculator or whatever you can do, and use the Excel table, whatever, it will give you approximately 1.96. So this number is also very famous, 1.96, approximately 2. So many people who are not familiar with statistics still know plus minus 2. Approximately plus minus 2 is the interval we use. But no one knows, not many people know why plus minus 2 is important. The idea is coming from here. So because plus minus 2 contains 95%, and 95% is the most common confidence level we use in practice. So now we can match these two equalities. Then this guy equals this, right? 1.96 should be m over sigma over square root n. But what we are solving for here is m. M is our unknown. So you are going to write m, the margin of error, what we want you to calculate, in this way. But still there is a remaining problem. So, and sample size is known. Sample size is usually known, of course. But sigma is the population standard deviation, which is unknown. So you have to replace this guy with an estimator for that. So, like for example, sample standard deviation can be used in this place. And then using this, calculate the standard deviation from your data, and then you can calculate the margin of error using this formula. So in the end, the confidence interval is pretty simple. You have to calculate x bar, the sample average, which is really simple, easy to calculate. And then you have to find this value, 1.96, according to the confidence level. So if you use different confidence level, this value will change, then this value will change too. So this follows from confidence level, and then sample size is known, and standard deviation you can calculate. So in the end, you only need four numbers: sample average, sample standard deviation, sample size, and this number, z value. I will call this z value later. So in the end, what you need is those four numbers and follow the formula. That's it. So this is a general case scenario without specifying the confidence level at alpha, 95%. But I will leave the confidence level as 1 minus alpha. So 1 minus alpha is the confidence level, or alpha is the error probability. Error probability is I will allow alpha percent error probability, and then everything is the same. This probability equals now 1 minus alpha, and standardization is exactly the same. X bar should come to the middle, right? And standardize X bar, then it becomes standard normal distribution. And the other sides have simpler, like simplified to m over sigma squared n. Plus minus m over sigma over square root n is the probability 1 minus alpha. And then you have to find, the problem here is, in general, with alpha, you have to find value a, that corresponds to this. Then the same rationale holds here. So error probability is alpha. So in the middle, there is 1 minus alpha probability, and outside, on each tail, there is alpha over 2 probability on each side. So you have to calculate probability with respect to alpha over 2 now. So simply speaking, we may use A, which is top alpha over 2 probability value, which we denoted in this way in chapter 6. When we learned normal distribution, we learned this notation. Lowercase z subscript alpha is top alpha probability value, right? And then you may use like normal distribution table, calculator, like CDF, whatever, to find this value. Usually, a calculator must have simple way to calculate this, right? But what's interesting here is the error probability was alpha, but you have to use alpha over 2 on the calculator, because, as I said, error can happen on the negative side and on the positive side. So you have to split the probability half and half on each side. So z alpha over 2 is a general form. So this z value, given this z value, which depends on the confidence level, the confidence interval will be calculated this way. Again, it's pretty simple. Sample average, simple. This part requires a little bit of exercise, but if you become familiar with calculator, computer does it for you. So easy. Calculating the standard deviation, easy, right? Sample size, also known. So in the end, the conclusion is pretty simple. Confidence interval is calculated this way for the population mean. Okay, this is the simple conclusion. You need only four components, and each of them are easy to calculate, and we learned how to calculate them, and then just assemble them in this way. That's it. Uh, and time is up, so I am going to explain the intuition behind it, and we'll give you an example, actual example, how to use the formula, this results. Okay, see you in the next video.